Greetings, everyone. Thank you very much for joining us in our today's session. So, today we are going to be looking at linear programming or the LP model. So, linear programming is a mathematical technique which is used in allocating scarce resources in an economic. So we use the LP in order to allocate scarce resources. So the scarce resources that we are talking about here, we have labor, capital, and so on and so forth. So in our today's session, we are going to look at how we can solve problems or issues which are related to that. So we are just quickly going to jump into an exercise and then handle it together. So we are going to solve this exercise which goes thus. This is an exercise. They say a firm manufactures two products A and B on which their profits earned per unit are 3 francs and 4 francs respectively. Each product is processed on two machines M1 and M2. Product A requires 1 minute of processing time on M1 and 2 minutes on M2. While B requires 1 minute on M1 and 1 minute on M2. Machine M1 is available for not more than 7 hours. So this is the maximum number of hours that this machine has. 7 hours 30 minutes. While machine M2 is available for 10 hours during any working day. So it cannot go above this. Find the number of units of products A and B to be manufactured to get the maximum profit. So there are several approaches. Either we use the graphical method or we don't use the graphical method. The highest thing is that we should arrive at the required destination. So we are quickly going to start solving the problem. Let me increase my sheet. So solution. Solve solution. So the first thing for us is to identify the activity variable. So what will be our activity variables here? Since we are dealing with product A and product B, so we can just say that one. So the first thing is the activity. So let the units of product A let the unit of product A equals x1 and the units and that of B equals x2. So this is our decision variable, and then the next thing is for us to state the objective function. Just write objective function. So in this case, they are talk about us manufacture that the units of A and B to get the maximum profit. So we are going to maximize Z, which will be, so we are going to use the profit from the question. So they say if a manufacturer two products on which the profit per units are 3 francs and 4 francs. So our objective function will be to maximize Z So we have the units, which are 3 francs and 4 francs respectively. Meaning for A we have 3 francs, will be 3x1 plus 4x2. So this is our objective function. So this is our objective function. Now the next thing now for us now is to state our constraint. So each organization, they always have as their primary 2 main objectives, which is either to maximize profit or to minimize cost. So in this context, we are maximizing our profit. So the next thing is for us to state the constraint. Before I state the constraint, I would like to present all this information on a table. So I can put here the can put A here, A, B, can put your required minutes. So I have machine 1 and machine 2. Then let me just put the profit. So let's analyze the question together. So the question goes, they say A and B, the firm manufactures 2 products A and B on which the profit per unit are 3 francs and 4 francs. So the profit per unit of A is 3 francs and that of B is 4 francs. And then the further says each product is processed on 2 machines. These are the machines that we have labeled M1 and M2. Product A requires 1 minute of processing time on M1. Product A requires 1 minute, meaning under here 1 minute of the processing time on M1 and 2 minutes on the processing time on M2. So M2A we have 2. Then let's continue. Why B requires 1 minute on M1, 1 minute on M1 and 1 minute on M2. So 1 minute on M2. Machine M is available for not more than 7 hours. So we have 7 hours. 7 hours. 7 hours 30 minutes. Why machine M2 is available for 10 hours during any working day. So M2 is available for 10 hours. Gonna put this in a table format. So this is our small table. Then so this 7 hour 30 minutes will convert everything to be in minutes, since our available minutes time here, duration here is all in minutes. So we'll change this to be in minutes. So this 7 hours 30 minutes will be something like 7 hours. We have 7. Each minute is each hour is always equal to 60 minutes, right? So we are going to take 7 times 60. 7 times 60. And then plus that 30 minutes that we have there, plus 30. So this is what we have done. Sorry. All right, so we have 450 minutes that we use. Then concerning 10 hours 2, we are going to take 10 times 60 as well. So we are going to have 600 minutes. So we are going to have 600 minutes, and we have 450 minutes and 600 minutes. So now what will be the next thing? Now the next thing is for us to state our constraints. So this is the profit as we have stated in the objective function. We have this. Alright, please. So from this table now we are going to state our constraints. So the constraint for machine M1. Machine M1, we have one unit here and one unit here. So we are going to have 1x1 plus 1x2. Since the coefficient of x1 here is only 1, we are just going to write x1. And here, since the coefficient of x2 is also 1, we are just going to write x2. Please, when the coefficient is 1, we don't write it. We just allow it like that. Right? And here, where the coefficient is 2, we are going to write the 2x1 plus 1x1. So with machine M1, we are going to have x1 plus x2 should be less than or equal to 450. Then machine M2, we are going to have 2x1 plus x2 should be less than or equal to 600 minutes. So these are the two constraints. So now the next thing is for us to state the non-negativity constraints, which applies at the end all our values, we should come up with a positive result. So we says our x1, x2 should be greater than or equal to 0, meaning nothing should be there which is less than 0. All right, so we are going to solve these two equations, these two simultaneous equations. So in this context, we are not using the graphical approach, so we are going to solve the equations normally. So we are going to transform the equation now to these inequalities now to equation signs. So we are going to have x1 x1 plus x2 should be equal to 450. The second one, 2x1 plus x2 should be equal to 600 minutes. So these are the two simultaneous equations that we have to solve it. So we are just going to go by the elimination method. So looking at this equation, when we have x1 here, we have x2, 450, we have 2x1 here, we have x2. So the coefficient of x1 here is 1 and the coefficient of x1 here is 2. But this second variable, the coefficient of x2 here is 1 and the coefficient of x2 here is 1. So we are going to take equation 1, take away equation 2. So we can call this equation 1. Right, so with the simultaneous equation, please, when you come, you have to label them. we have numbered this one equation 1 and this other one equation 2. So we are just going to take equation 1 take away equation 2, or you take 2 take away 1, you will arrive at the same situation. So since you have 2 here and 600 here, I will prefer and take equation 1. So let's take, so we are solving by the elimination method. The elimination method. Alright, so I hope you guys are following. So we are going to take equation 2 take away equation 1. So we take equation 2 take away equation 1. So we are going to have 2x1 take away this. So we have, we use big brackets now. Of 2x1 take away x1 plus x2 take away x2 should be equal to 600 take away 450. Right, so the coefficient of x1 here is 2 and the coefficient of x1 here is 1. So we always work with the coefficients, please, if you are confused. So what will be 2 take away 1 will be 1, right? So we are going to come up with x1 alone. So x1 plus x2 take away x2 is going to give us 0, which is equal to 600 take away 450 is obvious 150. So x1 is equal to 150. All right, so our x1 is 150. This is the value of x1. So we are going to take this x1 and substitute either in equation 1 or equation 2. So now we substitute. X1 in equation 1. So meaning anywhere we see 1 x1 in this equation, anywhere we see 1 in this equation, where x1 in this equation, we are going to put 150, which is the value of x1. So we are going to now have 150 plus x2 should be equal to 450, sorry, 450. So x2 will be equal to 450, 450, take away 150. So 150 is going to cross to the other side, so the constant should be on one side and variable should be on one side, right? So our x2 will be equal to 450 take away 150. Let me punch. $450 less 150. Yeah, it's 300 francs. So of 300. Alright, so what was the question saying? That find the number of units of products A and B to be manufactured to get the maximum profit. So all these are answer, please, they're in units whatsoever. X1 is already representing the unit rather. So with product A, we have to manufacture product A. We have to manufacture we have to manufacture 150 units and B units. So we have to manufacture 150 units of A and 300 units of B in order to maximize profit. So what will be our profit now? So our objective functions, we have maximizing Z. Our objective function, we have this 3x1 equal plus this. So our profit, so this is the units of A and B that I have to manufacture. If in case now for you, if you want to know the profit that they can generate at the end now, you're going to have to take 150 and substitute in place of X and 300 and substitute in case of X2. And let's just try that. So let's just try it. So we are going to have 3 now into 150 into 150 plus 4 into 300. So 3 times 150 is something like 450 plus 4 times 300, 1200. So what will be the sum? Let me use the function. Whatsoever. So we are going to have 1,650 francs. So this is our profit. So this is our profit. So thank you very much for following. You can always drop your questions in the comment section and your comments, then we are going to pick you up from there. Thank you very, very much. Feel free to share and also to like and subscribe as well. Thank you very much. See you next time.